All right, so reciprocal functions. All right, reciprocal functions. This is almost the same thing as what we were doing yesterday with inverse. Because in yesterday, and it's basically the same thing, but we're going to just change it up just a tiny little bit when we're going through these. The big thing is with reciprocal functions is it's going to start off with f of x equals 1 over x. Or depending on if it's an equation, then it's y equals 1 over x. So yesterday we were doing for inverse, it was y equals k over x. Today it's y equals 1 over x. So it's still kind of the same thing for that one. And now if we're doing this, let's kind of go back in time here. What's the one value for this particular equation or function that you cannot have? X can't be 0, right? Because if x equals 0, then it's undefined. So the value that you cannot have in this case, you cannot have x equal to 0. So here's something that I think we've kind of danced around a little bit, but we haven't actually talked about it, like specifically what it is. But asymptote. All right, an asymptote basically is this. This is a line that a graph approaches, but never touches. All right, and for this particular function that we're working with, if we're talking about just a reciprocal function of what's here, f of x equals 1 over x has two different asymptotes. And a lot of the functions that we're going to work with tomorrow, we're going to do the same thing, but they just get a little bit more complicated. The first one we're going to do is that if we do it, that basically this is one of those things where if you've got x equals 0, it makes it undefined. So for that one, we're going to say that we have a vertical asymptote. And so we'll have to spend the whole time writing vertical asymptote as we go through these. We'll just call it VA for short. At that value. So whatever makes this thing undefined, when we're talking about that x cannot equal 0, that's basically an asymptote. That when you get to that point in the graph and you try to put that point on there, it doesn't exist. It's not on the graph. So that's going to basically be that we've got an asymptote there. All right, the second kind we're going to have with this particular function is a horizontal asymptote. And for short, we'll just call that an HA. Ha. And that's going to be at y equals 0. Okay. All right, now we're going to go ahead and graph this thing. Now, here's where it's going to be similar to what we did yesterday. When we're doing these particular functions, the top number that's here can change. So if it's 1 or 2 or 3 or 4 or 5 or 6, kind of like we did exponential growth, it's still going to be the same basic graph of a function. So it doesn't matter when we're doing this f of x equals 1 over x. This can be 1 or 2 or 3 or 4 or 5 or 6. And it's still going to be basically the same graph. It's just going to tweak and turn just a little bit. So if we want to graph, let's say y is equal to 6 over x. Then whether it's 1 over x or 6 over x, it's going to be the same basic shape of the graph. Just the curve that we're going to have that we'll see in the graph will be just a little bit different. All right, so what we're going to do is we're going to go back over and we're going to make a nice old-fashioned T-chart to start with. And we're going to plug in some numbers. Now, the good news is you don't have to do this after the first time we do this, because after we do it the first time, we're going to basically show you the shortcut of how this thing will look and kind of what you can do to kind of make some things go a little bit faster for this thing. All right, so let's plug in x equals 1. Yeah, 6 divided by 1, y is 6. Okay, now let's pick the numbers that are easy to work with. Obviously 2. 6 divided by 2 is 3. X is 3. 6 divided by 3 is 2. We're going to skip over 4 because we'll get a decimal number. We don't really need 5. So then we'll go to 6. And 6 divided by 6 is 1. Okay, pretty easy on that, right? Again, pick numbers that make it easy to work with. We're not going to worry about picking, 4 or 5 where we get decimal numbers. We're just going to do whole numbers. So if we graph this thing, all right, so we've got the points at 1, 6. So over 1, up 1, 2, 3, 4, 5, 6. Okay, so there's a 1, 6, 2, 3. Go over 2, up 1, 2, 3. We're over 3, 2, and then 6, 1. All right, now if we were to connect the points in between, if we were to put in like 4 in here, 6 divided by 4 would be like 1.5. So it would be something like that. 5 would be 1.2. And if you start connecting the dots, it's got this curve. It looks something like this. And if you keep stretching this thing out, it's going to keep going this way. So it gets closer to the x-axis here. If you stretch this one out, it's going to keep getting closer and closer to the y-axis. Okay. Oh, now one thing I forgot to put back here. When you draw these vertical and horizontal asymptotes, I should have put that. I totally forgot there. Yeah, looks like a slide. When you draw your vertical and horizontal asymptotes, use dashed lines so that they stand out when you're doing the graph. Because everything else is going to be solid lines. But vertical asymptotes and horizontal asymptotes, and in every situation that you look at, they're always going to be shown with dashed lines when you get these. Okay, so again, whether it's 1 over x or 6 over x, you're going to have a vertical asymptote and a horizontal asymptote at x equals 0 and y equals 0. So basically, if we were to go back and draw a dashed line on top of it, you have that. And you have that. Okay, and basically what it is, the asymptotes are they're boundary points, that they're like fences, that those kind of keep everything in a certain area, so that if you were thinking about somebody's yard or whatever, these are your fences. So if you've got something in here, then basically you're keeping everything contained in this yard, so that nothing really gets out of that area. Okay, now that looks pretty similar to the exponential equations. The big difference is when we're doing exponential equations, it was always going to cross over here at 1 on the y-axis, and then it would turn and go up like that, or it would come in and do something like that. So that was the big difference, is when we were doing exponential graphs, if it was exponential decay, it would have been back on this side of the line, and then it was going to cut back and come back closer, but then it was still going to get really close to 0. The big difference is with inverse or the reciprocal functions, it's going to stay inside your x and y axis there. Okay. All right, now we're not quite finished with that one, though. Because what happens if you plug in a -1 for x? What does that change in your answer? Just makes it negative, right? Yeah. Just flips the signs around. So if that's a -2, you get a -3. If that's a -3, you get a -2. If that's a -6, you get a -1. So that's kind of a quick, easy way to do it, so you don't have to keep making more points on that one. So now we can graph these points to see what would happen when we plug in the negative numbers. So now we're at -1. So -1, -6 would put you down here. -2, -3 would put you there. -3, -2 would be there. And then -4, 5, 6, -1 would put you here. So basically, it's the same graph as this one, but now it's going here. And again, you still got your asymptotes that are saying, all right, if we're inside here, we've got to stay inside this box. And technically, those asymptotes go forever, just like the graphs would go forever. Okay, and then some of the details that we'll get for this part. We've got our vertical asymptote. There's going to be at x equals 0. Our horizontal asymptote, because it's horizontal, again, that's the one that's going this way, vertical is going that way. So vertical asymptote at x equals 0, horizontal asymptote at y equals 0. If we talk about domain, all right, now if you look at the graph though, domain is your left and right movement. You go to the left forever, correct? Then you come in and you get really close to your horizontal asymptote you got here, or your vertical asymptote you got here, and then you pick back up here and go this way. So you get really close to 0, but you never quite get there. So that's one of those you can, and again, this is where we can do it a couple different ways. You could say that it's negative infinity to infinity, but x cannot equal 0. And your range, same thing, it's negative infinity to infinity, but in that case, your y cannot equal 0, because now you're going to do the same thing. You're moving from the bottom till you get up to here, you get really close to 0, and then you pick back up over here, and then you move that way. All right, now the other, and again, sometimes with that one, they may show the domain and range that way. They may also show it where it's going to strictly go with interval notation. So if you do interval notation, that would be from negative infinity to 0, and then put your union, and then 0 to infinity. And then range would basically be the exact same thing, carbon copy there. Because basically you're skipping 0 on the x-axis and you're skipping 0 on the y-axis. So it may list it like this. It might list it like that if they have you start talking about domain range. I don't remember which one Math Excel asked you to do. Okay. And again, the only difference on these graphs is that if this had been 2 over x, this graph might be a little steeper over here or over here. But as far as like basic shapes of it go, you could put any positive number here and it's going to look like that. Yeah. Okay, so that's kind of the next little thing. We're going to just put stuff into categories and tendencies and how stuff's going to happen here. That if you have y equals k over x, if we go back to what we were doing yesterday with the inverse functions, that if we tie back in straight to what we're doing yesterday, if we had y equals k over x, if we make it an inverse function, if k is positive, so if your k is greater than 0, the graph will always look something like that. So it doesn't matter if this is 1 or 2 or 3 or 4 or 5 or 6, it's always going to look that exact same way. All right, and then if k is negative, what do you think it's going to be? Yeah, just do the other spots, right? So that if k is negative, if it's a negative divided by a positive, then that means this answer is also going to be a negative. So it's going to be like a negative kind of thing, or depending on what numbers you plug in here. So this one's basically going to take the other spots. You're going to have one here, and you have one there. Okay, now here's more of the problems that you're going to have to do that you won't actually have to do this. And this would be where it'd be more multiple choice. That you're going to have some different equations set up, and it's going to ask you to pick you might ask you to write the equation for it first. And then after you do that, it's going to have multiple choice where you just pick the right graph, and it'll be pretty easy because there's not going to be a whole lot of options to it. Okay, they ask you to graph this thing. Basically, that means you need to solve for y. And usually there's not a whole lot to do. To solve for y. In that case, you've got to get rid of the x, so we're going to divide both sides by x. Okay, so y is equal to negative 20 over x. And once you get it here, again, this is where it's multiple choice, that if that k value is negative 20, you know the graph has to look like that. So that's where we can just do a quick sketch of a graph. So it looks something like that. Okay, so for reciprocal or inverse functions, that's going to be your graph every single time, and it's all going to be based on what this number is. If it's negative, it's here and here. If it's positive, it's here and here. And that's just based on your signs of dividing positives and negatives, and putting in the right places on those when you go through that. So if the k, that's it. Okay, now the one other little thing we're going to add in with this one, for those parts, is we got to add in some translations. Of course.
Every time I get it, and then we add something and I don't get it.
But this is the same thing we've done like 4 different times, so hopefully this will kind of kick in. Okay, so we got to do some translations. And this is just like the translations that we did when we were doing quadratics. How if you had started with x squared and you put a number on the inside of the parentheses and you put a number on the outside of the parentheses, how it would move it up and down and left and right. Same thing we did with exponential graphs. Same thing we did with square roots. Same thing we did with x to the third. Same thing we did with basically every graph that we've done so far, is that if you have y equals something over x, and here's what we're going to, instead of calling it k, now they're going to call it a. And then if you add or subtract something on the denominator, and you add or subtract something on the outside of the denominator. Okay, so that was basically our original problem that we had. Now we've got something added or subtracted here. Now we've got something added or subtracted here. This is inside the denominator. So when you pull that number out, change the sign of it. That sound familiar? Number on the outside that you're adding or subtracting, you don't change the sign of it. So now HK, that's again your center of the graph. All right, and remember when we graphed quadratics, what the H and the K stood for? H was your horizontal movement, and K was your up and down movement. This one's going to be the same thing. So H is your opposite horizontal movement. Yeah, center.
I thought it was into it.
Oh, no.
With the parentheses. Okay.
Sorry. Yeah, that's center with a C.
Gotcha.
All right. And then the K, that's going to be your vertical movement in the normal direction. You ready to graph one of these?
No.
Too bad. We're going to do it anyway.
And then are we done?
Yeah, we'll do like 2 of these. And then should be pretty much done.
What do you mean pretty much?
I always leave that wiggle room in there.
I'm
No.
funny. Did you like my comment back?
Okay, so let's graph it, and we're going to state the domain and range. Okay, so we're going to graph it. We're going to state the domain and range, and we're also going to state what the asymptotes are. All right, so we're going to start with 4 over x minus 3 plus 2. All right, and again, what we're doing last time, we were basically just doing 4 over x. We're adding in the 3 and the 2. Say negative 3, so we're going to go 3 spaces, not to the left, but go 3 spaces to the right, because anytime it's on the inside of whatever, in this case, we're talking about the denominator, because x is in the denominator. Anytime it's in that area that we're working with it, you always go opposite direction. So we're going to go 3 spaces right. 2 on the outside means we're going to go 2 spaces up. So we're going to take that graph that we had before, where we had the graph here, and everything was at 0. Now we're going to move it over 1, 2, 3 spaces, and then up 2. So instead of the asymptotes being at 0, 0, now the asymptotes are going to be at over 3, up 2. So now your asymptotes are going to be right here. So now we're going to go this way and that way. Okay, so all we've done is we've moved the center of the graph, which is where the asymptotes crossed each other. We've moved it 3 spaces right, 2 spaces up. And then here's where the part gets easy. This is a positive 4 on top. So if that's positive, that means you've got to be here and here. Okay, and as far as graph-wise goes, that's how easy the graph should be. Now we got to do the other couple of things. All right, so vertical asymptote is always really easy. It's whatever's with the x that's here, that's in your denominator. So whatever this number is, it's there. We move 3 spaces to the right. Now you're hitting the x-axis here at 3. So your vertical asymptote is x equals 3. All right, your horizontal asymptotes, that's where you're going to use this number on the outside, which basically means now we're going to x, y equals 2. So horizontal asymptotes is going to be y equals 2. All right, and for your domain, negative infinity. But when we get to 3 on the x-axis, we're skipping over it, right? So we're going to go from negative infinity to 3. We're going to jump over the 3 and then go to infinity. And then for your range, we're just going to use the y value. We're going to start at negative infinity. When we get to 2, we're going to jump around it, and we're going to go 2 to infinity. So the numbers, this is the part where it gets really easy. All the numbers match up when you go through this thing. Whatever's in the denominator with the x, you change the sign of it. That's your vertical asymptote. That's also what you're going to skip in your domain. The other number that's on the outside, that's your horizontal asymptote. That's what you're going to skip in your range. All right, one more and we're done. All right, So let's go with y equals -2 over x plus 6 minus 7. All right, first thing we got to do is just figure out what our movement is away from the center. And again, whatever number is in the denominator, that tells you how much to move left and right opposite direction. So that's 6 to the left. -7, it goes your vertical direction, 7 down. Okay, and again, these are telling you, these up, down, left, rights are telling you where we're going to move the center of the graph. So instead of the asymptotes crossing at 0, 0, now we're going to go 6 left and then 7 down and put it there. And that's where basically the asymptotes are going to cross over each other. Okay, and then the only other thing is it's a negative number on top. So that tells us which parts of which corners we get the graph. If it's positive, we're here and here. Since it's negative, we are here and here. All right, vertical asymptote. It's always the denominator part. So in that case, it's equal to 0. So your vertical asymptote would be at x equals -6 because we moved it 6 left. Horizontal asymptote, that's the other part of the second number here. So that's your y value. That's your up and down movement. So that's at y equals -7. All right, domain and range. Domain, we're going -infinity, and we're going to skip over our vertical asymptote. So we're going from -infinity to -6. Skip around that and go from -6 to infinity. And then horizontal asymptote, exact same thing, but we're going to use the y value to then get a range. Okay, now, and in this case, I don't know that they would ask this question, but some of the basic problems when we were doing these kind of problems back here, they might ask you to find the x and y intercepts. But the good thing about this one is if you're skipping the x value of 0 and the y value of 0, do you ever cross the x or y axis? Yeah. So in this case, if they ask you a problem like this one doesn't have any vertical, this doesn't have any x or y intercepts because you never touch the x or y axis. I don't know that they would ask it on this one because you can find them, but they're going to be very, very interesting numbers. They're not going to be like easy whole numbers. They're going to be decimal numbers. So I doubt that they're going to do that. If they did ask for the x or y intercepts, you plug in x equals 0 and then solve this equation to figure out what it would be to find the y intercept. And then over here, you plug in the 0 for this, and then you solve this thing for x, and then find out what the x-intercept would be. And they're almost always going to be decimal numbers, so I doubt they would do that because it would be hard to find out specifically what those numbers would be. But there's a possibility they could do that.